Hey guys, how you doing? It's Coach Scott, and I'm in the third video on this series in Unit 6 on intermolecular forces. So let's look at some of these, okay? And how do these IMFs affect physical properties? So, the strength of the attractions, all right, between these molecules or between these particles will affect the properties of a substance or a solution, okay? Definitely. So if you look right here, you've got two different liquids, right? And it's asking you a question because we have, if you have a resistance to flow, we call that viscosity. Motor oil will have a greater viscosity than like liquid water or alcohol or what have you. And if you think about it, the viscosity or this resistance to flow, okay, is just really a measure of how easy it is for these molecules to flow past each other, right? All right. So viscosity is going to increase with a stronger intermolecular force, and it's going to decrease with higher temperature. So out of curiosity, okay, which of those would be more viscous? The purple one or the clear one? Well, I'm thinking the purple one has more resistance to flow, so I'd say that's the higher one. So let's look at some things, right? We've got several organic molecules, some no-names, okay? We've got hexane, okay, which is C6H something. H3, 6, 2, 4, 6, 8, C6H14. Okay. We've got heptane, that's 7 carbons. We have octane, that's 8 carbons. Nonane, that's 9. And then we have decane, which is 10 carbons. So these are chained organic molecules, hydrocarbons. And if you look at it, right, the viscosity as the molecule gets bigger goes down. I'm sorry, it actually increases. -4, -3. So the viscosity increases as the molecule gets bigger. And what are we thinking is going on there? Probably increasing London dispersion forces because the molecule's getting bigger. You have more electrons going on right there. So that's really a measure of the increasing LDF. Now, surface tension. That's another one. You may have heard of it before. You might have seen these little water striders that go over the water. So surface tension results from a net inward force experienced by the molecules on the surface of the liquid. Okay? So the surface tension of the liquid is directly related to the attractive forces between its molecule. The stronger the IMF, all right, the stronger the attractive forces, the more the surface tension is needed to increase the surface area of the liquid. So water has a relatively high surface tension of 7.29, you can read, times 10 to the -2 joules per square meters at 20 degrees C. But mercury's is even higher, all right, has a higher surface tension at 4.6 times 10 to the -1, or 0.46 joules per square meters. Why do you think mercury would have a higher surface tension? Let's think about it. Look on a periodic table. What is mercury compared to water? Mercury is a metal. Mercury is a metal. So those metallic bonds are stronger than the hydrogen bonds of water. Okay. All right, moving on. So a substance's viscosity is directly proportional to the strength of its intermolecular forces. Is that true or false? Well, I'd say it is true. The stronger the substance's IMF, the greater its viscosity. Which of the following substances would have the greatest viscosity? And we're looking for the one with the most electrons, if you would. And of course, that would be C. I don't know what that is. We'd have to count it. I think it's octane. So that would be C. But I can tell that there's more carbons than any of the other ones. The unbalanced attraction of molecules at the surface of a liquid tends to pull the bulk of the molecules let's see, inward, outward, in all directions, leaving a minimal amount on the surface. And of course, that's going to be inward. All right, so it's going to pull those molecules inward, leaving a minimal number on the surface. All right, so those are the two physical properties that we can look at with IMFs that are directly related to the intermolecular force. So we talked about viscosity, we talked about surface tension. Okay, guys, this is Coach Scott. This is a pretty short video, and we'll move on to other bigger and better things later. So Coach Scott saying deuces.